Okay, just give me a minute. I'm setting up the live streaming. And once that is done, we will start. Okay, I think we are live. We are good to start. We are going live on Instagram, Facebook, LinkedIn, and YouTube. Hope you can hear me clearly. Let me also turn on my video. Yeah. Um, can you hear me? Can you just mention in the chat if you can hear me? Just say yes.
Yes,
Also,
yes.
if you
Good
can
morning.
just let me know.
I can hear
Okay,
you.
thank you, Swarup. Thank you, Banu. Okay, thank you, Vedran. Welcome, everyone. Yesterday, we had some technical issues. Not many people received WhatsApp group link, but today there are already more than 60 people in the WhatsApp group, and still some people did not receive. Unfortunately, for some people, the email might have gone into the spam or junk. So if you are watching this on social media, this stream, if you filled the form from the website, please check your inbox already if it is not crowded, or please also check your spam and junk folder. You will have a WhatsApp group invitation link. You have to be in the WhatsApp group to receive Zoom link and Google Drive link. Otherwise, there is no way you can get the uh, Zoom link or Google Drive link. And the group is also not public, so you can't join. Even if someone shares you the group link, you can't join. We have to accept you. We will only accept you if you fill the form. So this way we make sure that only the right people are joining and it is not open for everyone, as everyone's WhatsApp contact details will be shared. So we want to have like-minded people who wants to learn software testing, basically, not just open for public. So in most of the WhatsApp groups, people just join and do nothing. So this is not such a group. So this is a group where people will actually attend the classes and get the drive link to get study material, recordings, and other stuff. Okay. I see some people already joined yesterday in the manual testing class. Sorry, in the automation testing class in the evening. We also have our automation testing with Playwright and AI at 7:30 p.m. IST, 4 p.m. CET. And in US, there are different time zones, but I think it will be in the morning for most of the people in the US. So you can join that session as well. The class link will also be shared in the WhatsApp group. For manual testing, Vedran will be your trainer and mentor. Vedran will be teaching. This week, we will focus completely on absolute basics. So if you already know a little bit about software testing, you might find it very basic, but that is the goal. We want to cover this for people who have no background in IT or software industry at all. It's people coming from completely different backgrounds, maybe medical background, civil engineering background, or maybe teaching background, or maybe someone who finished their graduation but never got an opportunity to work in any field, had a huge career break, but now wants to try to enter into tech and wants to see what it likes to be a software tester and what does a software tester do. So for keeping all types of people in mind, we are conducting these next 4 or 5 days of sessions. So this is for everyone. Uh, uh, but if you already know a little bit about software testing, or if you worked as a software tester, I recommend you to use this opportunity to help the beginners so that you can improve your maybe leadership skills or presentation skills or knowledge sharing skills. Knowing the subject alone is not enough if you want to excel in your career or grow in your profession. You should also be able to help others, guide others, mentor others. This period, you can use it to develop those skills if you already know what we are going to cover. Otherwise, you can just revise the concepts and get back to basics once again and learn and have fun. We already introduced ourselves many times, so I will skip the introductions part. About us, you can find us on our website, or I'll also share our LinkedIn links in the chat during the course, during the classes while the classes are happening. But I will hand over the session to Vedran. Vedran, over to you.
Yeah, good morning. I'm Vedran, so I'll be teaching this course for the most part. I think you're going to jump in a lot today, Jagadish.
Yep.
But a little bit about me. Yeah, I worked as a language teacher, and so in Swedish, SFI. So teaching has helped. Yeah, helping people learn has been a big part of yeah, my work. And it's actually more recently, I've been working with software testing. And this all started because I found myself interested in programming. So I just decided to explore the field, and I ended up in software testing. And I just wanted to combine my previous teaching experience with software testing. So I'm excited to share this technical knowledge and practical skills you'll need. And yeah, don't worry if you're a completely new to software testing. I was quite new recently, until quite recently. So we'll just take this step by step. And of course, I'll encourage anybody to ask any questions they have if something isn't clear. Yeah, Jagadish, do you have anything?
Nothing. The floor is yours. You can,
Okay.
yeah, take full control.
Okay. Let me share this. I have, let's see. I think do this. Do you all see? Do you see the screen?
Yes, we can see.
Okay, yes. So manual testing, yeah? First module. Okay. So yeah, today we're going to discuss what is testing and why is it important. Roles in testing, we're also going to discuss that. Who is a tester? What do customer want? What do customers want? What do companies want when it comes to testing and that relation? We'll be talking about 7 principles of testing. And these are like general guideline for testing. We're going to touch a little bit on the software development lifecycle, and then we're going to look at testing activities. Yeah, this will be a quite short introduction to all these topics. I think it's quite a lot to cover, but I will just explain it as much as I can in at least this session. Okay.
Vedran, sorry for interrupting.
Yeah, sorry.
So the presentation screen, it shows also the next slide.
Oh,
I'm not sure if it was intentional, or maybe we can just keep focus on one slide.
Yes, yes. Sorry, I actually have 2 screens now. I think I shared
Okay.
the wrong screen. Here we go, right?
Yes, perfect.
Yeah, yeah. So, yeah, so we're gonna look at these activities and these topics and see how much, yeah, we cover here. So what is testing? It is part of the software development process. It's a process of evaluating software and to find defects. Now, defects, it's a term that we'll tackle later, and verify that it works as expected. And the important thing is to you identify problems before users do. Of course, you don't want to buggy software. And you have to check also the requirements. So whenever you're testing a software, there's always requirements. What do customers want? How should it work? And based on that, you have to test. You have to make test cases appropriate to these sort of requirements. And testing also helps improve the overall quality of the product. Quality is another word that we will discuss a little bit later on. Okay, I have a question for you. Why is testing necessary? If anybody wants to answer that question. What do you think? Why is it necessary to test software?
Because we don't want when customer will buy something, or it's not allowed that time we find out that it's not working something.
Yeah, correctly, yes. You want, of course, you don't want a faulty product. But also, there is also another reason. Does anybody know?
Before testing, before giving the software to the client, we must ensure that the whole software which we are providing is bug-free, and its quality is according to the requirement which was provided by the client.
Yes. Of course, we have to look at requirements. And also, another huge thing with testing is, of course, safety. Here we have two examples. And the left example, of course, we don't want a buggy software. We might find minor defects, such as the one on the left. Quite a funny example there. But also there are more serious examples for the right pictures. This is a radiation therapy machine called the Therac 25, and it was a computer-controlled radiation therapy machine. In the 1980s, a couple of patients, I believe 6 patients, received a massive radiation overdose up to 250 times the normal levels. And this was all because the software wasn't tested properly. So this is a case study for software testing if you want to look into it. So in summary, software is tested because either you want to check for minor bugs, maybe design defects, but also more serious things which can cause harm or even death. So that is why software is very necessary. And a lot of companies allocate a big part of the budget for software testing. Yes. Yeah. So of course, software is created by humans, and humans make mistakes. And now also relevant to point out that AI also makes software, and AI also does make mistakes. AI is, after all, trained on human code. So we have to check both human errors, hallucinations that have been generated, and also defects can affect functionality, security, performance, and usability. So these are things that aren't, you would maybe say bugs, but it does affect how a user would use an app. Now, if you have a food ordering app and it takes you 30 seconds to finalize your order, is it really a good app to use for the customer? And of course, testing is necessary because finding defects early is much cheaper than finding them after release. Now, if you're still working on the product and testing it then, that's going to be a lot cheaper for the team and the company than after releasing. You release a product and you realize there's a big bug in it that needs to be fixed. That's going to be very expensive to fix. Testing reduces business risk and increases customer confidence. Yeah, with testing, you reduce any kind of risk, whether it be bad publicity of having a app that does crash all the time, or a security issue. Maybe all your data gets leaked. You don't want that, so you really want to test all possible areas that you can test. Let's talk a bit about test roles. Who is a tester? There's, of course, an allocator role, which is the tester. A tester designs and executes tests to find defects and verify that the software meets its requirement. So a tester looks at requirements and designs test cases and executes them. And then there's also test manager, plans and coordinates and monitor testing activities. So it's more like on an aggregate level. You have a test manager who can look at all the different kinds of tests, because in a process you might test different parts of a different product. Maybe you test the security, you test the performance. So a test manager would monitor all that and see if all goals are achieved. There's also the developer. Now, a developer can also be a tester, but the role of a developer is to write, maintain, and fix the software based on requirements and reported defects. Debugging, we'll get into that in a bit. And of course, there is business stakeholders. They define the business needs, they set the priority, and they ensure the software delivers value, it's delivered to the users in a good way. So all these roles, a tester can test. Of course, a test manager can also test. Developer is in testing, and business stakeholders are also relevant to testing. I want to talk about these three words. They come up a lot, and it might confuse some people. Errors versus defects versus failures. So an error, also called a mistake, that's what a human makes. Maybe you're sleepy, or it could also be badly generated code, hallucinations by an LLM, and you would have a mistake. And an error is also called a bug. Errors cause defects. So these mistakes that somebody is not trained in properly, or they made a mistake when working, that causes a defect in the software, in the code, also referred to as bugs. And the thing about bugs is they can be present in the code without a user or a tester knowing about it until they test the code, until they run the code. So if you execute a software with a defect, it will cause a failure, and that failure might be that the software crashes, it could be anything, that element you thought, so for example, if there's a website and you wanted the color green, but it turns out when you execute it, it's the color red, that is a failure. And the failure comes from a bug, and that bug has been inside the code or the software for a while. And it is only after executing it that you know that it is a defect. So yeah, errors versus defects versus failures. And as I mentioned, there is the debugging. Testing and debugging It is not the same thing. Simply put, testing finds bugs. We find the defects, and then a developer, a debugger, removes the bugs. So as a tester, we find these bugs through executing, or we could also if you review a document, you can see that this is a mistake here. This is going to cause a bug. It is the role of a tester to find this and report it to a developer, and they would then adjust the code and maybe ship it back to us where we test it again. Quality assurance and quality control. Now, if you've been in a different industry, it might look different. In IT, I think it works a little bit different here. First of all, quality, when it comes to software, it is the degree to which a product satisfies stated and implied requirements. So it has nothing to do with quality, say, for example, when it comes to food, it's been processed in a good way. It's for when talking about furniture, the material is good, it's not going to break. Quality is simply the thing that satisfies the implied requirements. So if you have a great product, but the customer didn't require some of the functionality, then is it really a good quality product? And testing, just to put it out there, it is a QC activity. It's quality control. QA uses test results to improve quality. So that's sort of the relationship we have there. We have validation versus verification. These are two very important terms. So verification simply asks, are we building the product correctly, as I mentioned, with the requirements? So if the requirements are, let's say we have a website, and the website is, we want the website to be blue, to have a gradient, it should have a drop-down menu, it should link to this, it should link to that. And developers might say, okay, we'll make it like that. And testing, it goes through testing, everything is perfect. But is it really what they want in the end? And validation is, are we building the right product for the customer? Even though requirements might be correct, we still have to ask ourselves, is the product built correctly for this specific customer? Let's see. So we have testing principles here. These 7 testing principles are fundamental ideas that guide software testing. They help testers focus their efforts effectively and understand the limitations of testing. They guide how testers think and work. And you don't need to memorize all this today, but I want you to understand the ideas behind these 7 principles. So the first one is testing shows the presence, not the absence of defects. Exhaustive testing is impossible. Early testing saves time and money. Defects or bugs cluster together. Tests wear out. Testing is context dependent. And the last one, absence of defects fallacy. Let me explain all those. So the first one, testing shows the presence, not the absence of defects. You have to, you cannot prove that there are no defects Testing reduces the probability of defects remaining undiscovered in the test object. But even if no defects are found, you cannot prove that there is none left. So a phrase like, there are no more bugs left to be found, something you probably never hear. You can never know. So yeah, it shows the presence, but not the absence of defects. Number two, exhaustive testing is impossible. Testing everything is not feasible, except in very trivial cases. Rather than attempting to test exhaustively, test techniques, test case prioritization, and risk-based testing can be used. So if you have a small application, it's quite easily, maybe in trivial cases, that you can test every combination of something. But as a software grows bigger, it will be much more impossible to test every kind of combination, especially if you have a website. You can, and the more elements you have, the more links you have to other things, and it just branches off infinitely, and testing every possible combination, or if you have an input, any number, it will be quite impossible to test every combination. If you have a website like Amazon, it links to payment platforms. So testing everything is just not possible. Okay, early testing saves time and money. Now, I want to ask you, how early do you think testing should start? And I do mean in the software development life cycle. If you're a tester and you're working with software, how early should you start testing? Any ideas?
As earlier as possible.
Early as possible. And how early would that be?
Even if you start to coding the very small part, you can directly it could be tested.
Yeah.
And once we get the requirement from the client, so we can start this testing process.
Yes. So
firstly, we need to gather the requirement.
Right.
As soon as the developers they start coding, and we get the requirement, so like the testing team, what we can do that we work with our we can create the data so that we can make our test cases according to the requirement, and then we can test the system accordingly.
So yes, you should start testing as soon as possible, and that does mean as soon as you have the early drafts, the requirements. Now you see here, the earlier it is, the cheaper it is to fix the defects. Now, if you have requirements, that doesn't even have to be code. You can just look at requirements and maybe analyze it and see, well, this is not possible. We cannot, maybe we can't build this website, or this doesn't really make sense. So we have to maybe ask and research, is this possible, and how do we talk to the client and just find out a way how to do this. So if there is a defect, or if you see that there's something that doesn't make sense in the requirements, you have to test it. And as you see, it scales up. Once you come to design, it will be 3 times more expensive. When you're designing the product and you say, hold up, now that we have designed this doesn't really make sense. We have to go back, we have to retest it. Once in development, when you're actually making the thing, 6 times more expensive. And testing, if you have the product and you test it and you realize there's a mistake, it is very expensive to go back. And of course, once you're in production, it's very expensive to fix that. Not to mention, if you already released the product, you would have to recall it, and that would be very expensive. So answer, you should start testing as early as possible, as soon as you have the requirements. Testing principle number 4, it is that the defects cluster together. And here we talk about a Pareto principle. A small number of system components usually contain most of the defects discovered are responsible for most of the operational failure. And this is an illustration of the Pareto principle. Predicted defect clusters and actual defects cluster observed during testing or in operation are an important input for risk-based testing. You will find 20% of the defects in 80% of the code. And the other way around, 80% of the bugs are found in 20% of the code. So all defects will sort of cluster together. And as an experienced tester, you will keep in mind that if you're good at maybe websites, or you're good at, have you worked a lot with food ordering apps? Maybe you worked with video games. You would know perhaps, okay, I've worked with this before. I think that there's a big chance that we will find 80% of the bugs in this part of the section of the code. Number 5, tests wear out. So if the same tests are repeated many times, they become increasingly ineffective in detecting new defects. Every method you use to prevent or find bugs leaves a residue of subtler bugs against which those methods are ineffectual. So if you have a login screen, say for example, and you run the same tests, let's type in the email, the username, let's type in the password, let's click login, you just keep doing that. But say the application grows and you have more links to the website and more elements, then doing the same test the exact same time, the exact same way, will actually be more ineffective as time goes on, because changing something in the software might change something else. So you have to keep in mind that these tests will wear out. And the reason they call this the pesticide paradox is because in pesticide, the bugs grow immune to the pesticide, so you have to keep remaking the pesticide for it to be again effective for the bugs. And the same way here, you have tests and you have to remake the test cases. You have to really look at them again and say, yeah, these are, we have to change this according to this. That website is now different, and we have to change the test, because otherwise it will not show any new bugs. You will not find any new bugs. But to overcome this effect, existing tests and test data may need to be modified. New tests may need to be written. But however, there are some cases where repeating the same test can have beneficial outcome. For example, in automated regression testing, and that's an automated testing, so it will not be so much relevant here. Okay, number 6, testing is context dependent. Okay, there is no single universally applicable approach to testing. And testing a video game is definitely not the same as testing a mobile phone app. You will notice that, if you have industry experience in testing video games, it will not be the same thing as testing a mobile app, or maybe if you or aerospace industry or any other industry, there is just too much different elements. So testing will never be the same in every industry. And the last one, absence of defects fallacy. This is a fallacy, and to expect that a software verification, and as you remember, verification, does anybody remember what verification was? Do you have Robert?
Yeah, if there is as I understood, if we follow the input from customer, if as much as possible.
Exactly. So we're talking about verification versus validation. And it is a fallacy to expect that software verification will ensure the success of a system. So just going off of the requirements will not make it successful. Thirdly, testing all the specified requirements and fixing all the defects found could still produce a system that does not fulfill the user's needs and expectations. And that does not help in achieving the customer's business goals and is inferior to other competing systems. So in addition to verification, validation should also be carried out. And validation, you remember, it was.
And what, I'm sorry to interrupt you, but as far as I remember correctly, you wrote there that if we are building that product right, that means that, for example, if we are building the for example AI for some weapon, and this weapon fulfill our requirements and kill the people, but these people will also suffer. So that means that we are not good in validation, because our aim was to just kill people, not also that they will suffer. Yeah. So
Yes. So that is the verification would be, are we building it correctly? So if you have the specifications, yes. In that case, you will build a military system that would destroy a city or kill people, but you don't want any suffering, then that is.
I'm sorry for that example. It's very
Yeah, no,
weird, but
Yeah, but sorry for jumping in. It's a very difficult question, but end of the day, the goal is to satisfy the requirements. So if the requirement is to kill someone or destroy a city, of course it is used in the military technology. You definitely do verification, validation against exactly that. So that's it. I mean, it is bad, we know. So no one likes, the wars and destructions, but it is the reality of the world, and people are building it, people are testing it. So yeah.
Yeah, of course, it all depends on who you ask. So verification, they told you build this and you did. And uh, then if something else happens after the product, now that would be a validation. For validation is, are we building the product, the correct product? Not are we, verification was, are we building it correctly? That is specifications, requirements. Validation would be, are we building the right product for the customer? Is this what they want? Now, yeah, you would never know. That's the customer. Yeah, there's a joke. Customer never knows what they want. So, of course, you can make the most perfect system, and customer might not want it, even if it's perfectly tested, doesn't have any issues. It does what they told it to do, they can still be unsatisfied with it. So that is the summary of number 7, the absence of defects fallacy. Even if there are no defects, it still might not be satisfied a customer. So it's a fallacy to think that we made this correctly, therefore it is perfect and they want the product. Not necessarily true. Okay.
Also, if I can also add,
Yeah.
like means what I understand that verification is static testing, like without execution of the code, like
No,
reviewing the requirement documents and the test cases.
yeah, it's to verify that the requirements are there. Are we building it correctly? And also it has, are we building the test cases correctly? It doesn't just have to be static testing. You can make test cases for any kind of test based on the requirements. Yeah. Yeah, any more questions? I hope I'm not going too fast. It feels like I am. So please ask anything. It'll take a couple of seconds if you can think of something, and then we'll move to the next slide. Okay. I think we'll keep on going. Oh. Right. I'm just going to very briefly talk about software development life cycle. This will come up later, but the development life cycle is a structured process used by teams to plan, design, build, and test, and deploy software. And yeah, its core stages include planning, coding, development, and testing to ensure the high quality and lower costs. And there are many models, although I will talk about the linear and iterative. So the first one is the waterfall model. We'll take a look at that next, but it is basically a linear model. You do the requirements, the design, and the development, testing, and then finally the production. It goes linearly, so you wouldn't go back to any step. Now, there are other agile models and spiral models and prototype models. These are more iterative, that you would do it in sprints. And here's an example of that. We'll do the, let's see. Yeah. the waterfall models. You would first have requirements, then you would finish that, and you would have system design, design the system, and implement everything. And then after that, you would do testing. So you wouldn't do testing in any of these other stages. So you do the thorough testing in this stage, and then you deployment is you would have the product ready and ready to deploy. Could be anything, software, website, or food ordering app, video game, a missile defense system. And then maintenance would be in the end where you still maintain the system. So this is linear. It goes one way. That's why it's called the waterfall. This is the oldest way of doing it. It's in very classical. I think you might find this in more legacy products. I think more government would use this kind of model because they would maybe know exactly what they want. Jagadish, can you pitch in a little bit about which industry this is mostly used in? Where would you find this model?
I mean, the 15 years back when I started my career, the very first project I worked was on waterfall model. So it is not specifically to, at least it was not specifically to any industry. Before Agile, most of the companies were following waterfall. But even now, there are some high sensitive softwares. For example, if you want to build a software for a flight, you can't use Agile. You need 100% ready to ship product. So yeah, similar, high sensitive areas use waterfall even now. But at least there was a time everyone was using waterfall. And when it comes to Agile, now everybody uses Agile. 90% of the software companies use Agile, unless the extreme examples, as I said, like if it's a flight industry or some other industries, they use waterfall. The good thing with Agile is you can ship the working product to customers in batches. So in every sprint, you will ship a working product to customers. Only where there is no possibility of such uh, flexibility to ship working pieces of product to customers, waterfall is suitable.
Yeah, so it's still persistent waterfall. It exists. It used to be, as Jagadish said, it is the classic model and was more common before. Of course, it still exists for in systems that require more security. Then there is the agile model, which is very different. You have different sprints, these stages, and
Vedran, sorry for interrupting. We are running out of time today.
oh,
Yeah, so we only
sorry.
have 10 more minutes.
Okay.
What we
Yeah.
can do, we can dig deeper into SDLC tomorrow, and we can conclude the session for today.
Yeah,
Yep,
sounds good.
yep.
Okay, do you want to take over then?
Yes, yes. So I will give a quick summary to everyone. And oh, sorry, why is my camera? Yeah.
Okay.
So I'll give a quick summary, and then we will continue to dig deeper into SDLC tomorrow. I just want to say one thing. If you're an absolute beginner, testing is manual testing, at least, is 50% theory, 50% practicals. If you haven't realized already, you have learned a lot of technical terms today already. So there was too much technical information already. But that's how it is. When you start doing the practicals, it will make more sense. So you have to be patient while you are learning the theory until you start the practicals. I will give a quick recap of what is covered today. You learned what is testing. You also learned why testing is necessary. You learned some key terms like error, defect, failure, bug, etc. And you also learned some roles of the testers like tester, test manager, developer, business stakeholders, etc. You also learned the difference between a QC and a QA. You also learned 7 principles of testing. And we ended with the introduction to software development lifecycle. And going forward, you will learn software testing lifecycle, bug lifecycle, software release lifecycle. So the technical terminology goes on. The 50% of it is about getting introduced to the terminology. So this is what I always say whenever I train or mentor people. Whenever you're learning, it doesn't matter any subject, it is tech, non-tech, or it doesn't matter any subject. The biggest blocker for first-time learners is the technical terminology in it. For example, if you want to learn artificial intelligence or machine learning, if I start saying something, deep learning, machine learning, classification, regression, random forest, if I start throwing out this terminology, you might think, oh, so it is very advanced tech, or maybe it just goes over your head, or you may not be able to comprehend the concept, etc. But if I, without using this technical terminology, if I just teach you the concept in a layman language, you would understand the concept anyway. So it is the technical terminology that is a big blocker for an absolute beginner. So the best way to learn anything is to get familiar with this technical terminology. So that's why what we do tomorrow, whatever the terminology you have learned today, there will be a quick test, like a quiz, fun quiz. And for first 15 or 20 minutes, we will have that quiz and test, and we'll have the discussion on the topics that are covered today. So, and then we will start the new topic again tomorrow. And then the next day, whatever the concepts we covered for first 2 days, we will have a quick quiz and test, and then we'll learn a new topic. So this way we can create a chain, and it's not just you listening in and then tomorrow showing up again to listen in. You also spend some time to get familiar with this technical terminology and do some study by yourselves and come prepared to the tomorrow's session, so that whatever you have learned today actually entered into your head. It is not just the information you got. So that is the pattern. So you have to put some effort from your side as well. You don't just come here and listen and then just disappear and then just show up again tomorrow. This recording will be shared in the drive. Vedran will also share some material and the slides in the drive. I hope you already have access to the Google Drive link. If not, I will share the Google Drive link right after this session in the WhatsApp group. You will get the access to the Drive link, and in that you will have several folders, recordings, study materials, assignments, etc. Whatever the assignments we conduct tomorrow, those will also be uploaded into the Drive, so you can continue to practice whenever you have time. Okay, so with that, we will end today's session. If you have any questions, you can ask now. We have 7 more minutes, or you can also ask in the WhatsApp anytime. Any questions from anyone? No, all good? Cool. So then, yep. Yeah, thank you, Olga. Okay, we can end the session for today. Thanks, Vedran. That was really a very good introduction to software testing. Looking forward to tomorrow's session. Have a nice day, everyone.
Yeah.
Bye-bye.
Bye-bye.
Thank you.
Bye-bye, everybody. See you tomorrow.
And tomorrow the same time, right?
Yes, the same
Yes.
time.
Thank you. Thank you.
Thank you, Vedran. Thank you, Jagdish. Yeah,
Thank you, Lydia. Hi, Lydia. How are you? Nice seeing you after
Yeah,
so
good,
long time.
Jagdish. How are you?
I'm doing good. Hope everything is fine.
Yeah, everything is fine. Hope everything is fine from your end as well.
Yes. Nice to see you after a long time. We'll keep in touch.
Yeah, of course. Thank you.
Yep. Bye-bye.